Hello students, in this video we will learn about integrals of the form e raised to power x fx plus f dash x dx. Right? This formula gives you the direct value of result as e raised to power x fx plus c. Right? And this is just an extension to the integration by parts concept, where you will get the form of e raised to power x fx plus f dash x. You can directly integrate it by using the formula e raised to power x fx plus c. So let us see how this formula is applied to the numerical problems. Let us start solving our exercise, the questions related to this formula. Okay. So first question which I'll take from this exercise 7.6 is your question number 16. And this question is integrate e raised to power x sin x plus cos x dx. Okay. So if I need to integrate this problem, okay, and I'm not aware of that formula, so how will I go for it? I will just break it in two integrals, e raised to power x sin x dx plus e raised to power x cos x dx. Okay. Now I can view that both these integrals, they are your product, right? They are involving the product of two functions, this one and this one. So I'll integrate by parts the first one, okay, and I'll not do anything to this second one, right? So integrate by parts this first one. So how integration by parts is applied? First function into second will be integrated as first into integral of second minus integral differential of first into integral of second, and this whole dx. Okay, so it will be your first function. Okay, so what first function I am going to take? I'll take this trigonometric as first and this one as second. Okay, you can take vice versa also. So first function is your sin x integral of second minus integral differential of first into integral of second and whole dx plus e raised to power x cos x dx. So it will be your e raised to power x integral of e raised to power x is itself into sin x minus derivative of sin is cos x, and integral of e raised to power x is e raised to power x dx plus e raised to power x cos x dx. So if we see, both of these integrals are same, and one is with plus sign, one is with other negative sign, so both can be cancelled. So I'm just left with e raised to power x, okay, sin x plus c, which is the required answer, right? So that's why whenever we integrate these kind of functions which are expressed in the form of e raised to power x fx plus f dash x, right? Okay, so we can directly write the answer by using the formula. Like here, this question can also be done by directly using the formula. And what is that formula? It is your e raised to power x fx plus f dash x is equal to e raised to power x fx plus c. Okay, so you can see that my fx here is sin x and the derivative of sin x is cos x. So this formula can be applied here clearly. So my answer will be e raised to power x sin x plus c. Okay, so this is how this formula can be used to all the problems which are of the form e raised to power x sin fx plus f dash x, right, to be integrated by e raised to power x sin x plus c will be the desired result. Now let us take your example number 20. Question number 20 of your exercise is integral e raised to power x x minus 3 upon x minus 1 whole cube and this dx. Now if you will observe this question, right, it is not looking like e raised to power x fx plus f dash x, right? But if I will express this complete term in such a way that it changes to fx plus f dash x form. So how will I do it? Right? I will break this numerator. Denominator is having x minus 1. So I'll break this numerator as x minus 1 and minus 2 upon x minus 1 whole cube dx. Okay. So this changes to e raised to power x. Now separate these two terms in the numerator. So break the numerator. It is x minus 1 upon x minus 1 whole cube minus 2 upon x minus 1 whole cube dx. Okay. So it changes to e raised to power x. It is 1 upon x minus 1 whole square minus 2 upon x minus 1 whole cube. Right. Now see from here, what is the derivative of x minus 1 say raised to power minus 2? So it is your minus 2 x minus 1 raised to power minus 3. So it is just x minus 1 whole cube minus 2 upon x minus 1 whole cube. So that means my question is expressed in the form of your e raised to power x fx plus f dash x. Right? It is your fx and this is your f dash x, right? So I can express it like this. Now it is specifically in the form of fx plus f dash x, right? Because the derivative is minus 2 upon x minus 1 whole cube, right? So the answer will be e raised to power fx plus c. Now who is fx here? It is e raised to power x and fx is your 1 upon x minus 1 whole square. So it can be written like this plus c, which is the desired answer. Okay. So there is no need to break this and then apply integration by parts. If this form is expressed specifically as e raised to power x fx plus f dash x, I can directly use this formula to get my answer. One question from your miscellaneous exercise in which this form is used, and that is your question number 25 from your miscellaneous exercise. And this question is integrate pi by 2 to pi e raised to power x 1 minus sin x upon 1 minus cos x. Now if you will look at this question, this form is not giving you directly e raised to power x fx plus f dash x result. Okay. But if I will split this numerator, that is 1 upon 1 minus cos x and minus sin x upon 1 minus cos x. Okay. So I can change 1 minus cos x as 2 sin square x by 2. And this formula for sin x by using the formula for sin 2a can be written as 2 sin x by 2 cos x by 2. I'll definitely be getting that form which I am searching for. Okay. So it is sin square x by 2. Okay. 1 upon 2 sin square x by 2 minus this is your 2 sin x by 2 cos x by 2. And this is your 2 sin square x by 2. This is dx. Okay. So this will get cancelled and I'll get it as pi by 2 to pi e raised to power x. This is cosecant square x by 2 upon 2 minus, I just get cot from here, cot x by 2. Okay. Now search here who is the function and who is the derivative. So I know that the derivative of cot x by 2 will be minus cosecant square x by 2. Okay. And derivative of x by 2 is 1 by 2. Right. So I'm getting here as plus. Okay. So that means my function itself is minus cot x by 2. Okay. Right. So let us arrange it in proper manner so that I can view the function and its derivative clearly. And this is your cosecant square x by 2. So this is my function and this one is the derivative. Okay. And this 1 by 2 is also there. 1 by 2 cosecant square x by 2. Now using the formula e raised to power x fx plus f dash x, what will I get? The result as e raised to power x fx plus c. Okay, so see what will be my answer? My answer will be e raised to power x, the function is minus cot x by 2. Okay, and since this is the question of definite integral, so no c, and I need to put the limits also. So let us put the limits. E raised to power pi minus cot pi by 2 minus your e raised to power pi by 2 into minus cot of pi by 4, because x is to be replaced by pi by 2, so pi by 2 upon 2 is pi by 4. Now what is your value of cot pi by 2? It is 0. And what is your cot pi by 4? This is 1. Okay, so this will be your e raised to power pi into 0 minus e raised to power pi by 2 into your minus 1. So this reduces to 0 and the answer is e raised to power pi by 2. So this is how we will be applying this formula e raised to power x fx plus f dash x, right, to evaluate those integrals which can be expressed in this form. And by using this direct formula, we get the answer in the form of e raised to power x fx plus c in case the integral is indefinite one, and by putting the limits as we did in this question, right, as desired for the problem. Let us take one more question, and that question from this exercise 7.6 I'm taking is your question number 21. Now this question number 21 is e raised to power 2x sin x dx. Okay, and in this question I must see that this is directly in the form of product of two functions. Okay, so I can integrate by using integration by parts, right? But one thing I'll observe that whenever I will be integrating it, you will get this sin x will give me endless integration, right? Sin will first change to cos, then cos to sin, and then sin to cos, and this process will continue, right? So what do we do in such questions? We will take this integral, okay? Let I is equal to e raised to power 2x sin x dx, okay? Now, whenever I'll get the repeated integral which is same as this one, okay, I'll put that one as I, and then I can integrate my question and can finish the integration instead of that repeated ones. Okay, so let I as e raised to power 2x sin x dx. So integrating by parts. Now you can take algebraic one as the first also, and this exponential as, I'm taking this exponential as first function and this algebraic one as second one. Okay, so let us see how integration by parts is applied. So it is first function integral of second minus integral differential of first into integral of second, and then this whole thing is to be integrated again. So it is your e raised to power 2x. What is the integral of sin x? It is minus cos x. Now ddx of your e2x is 2e2x into integral of sin x is minus cos x dx. Okay, so it changes to minus e2x cos x plus, take 2 outside, e2x cos x dx. Okay, now again this can be integrated by using by parts. Okay, so I'll apply by parts again. This is first, this is second, right? So originally to the left side we have I. Okay, so I is equal to this we have got right now. So it is I again is minus e raised to power 2x cos x. Okay, and then your plus 2 times, let's apply integration by part. First function integral of second integral differential of first into integral of second, and this whole dx minus e2x cos x plus 2 e2x integral of cos s sin x minus, this is your 2 will be coming from here. Okay, so 2 is coming from here, and ddx of this is your 2e2x into integral of this is sin x dx. So this I is equal to this. So minus e2x cos x plus 2e2x sin x minus 4 times integral e2x sin x dx. So I was saying this, that again e2x sin x has appeared. Again I'll apply integration by parts. In the next step I'll get e2x cos x. Then again this will continue, right? So what happened, that e raised to power 2x cos x was again integrated because this was a different term, okay? But this term is my original I, okay? So I'll resubstitute that. So how will I do that? From these two, I can take my e raised to power 2x common. So it is minus cos x plus 2 sin x, and this can be written as minus 4i. Now bring this to this side. So I'll get your I plus 4i as 5i. Okay. So it is your e2x minus, now integration is complete. So it is minus cos x plus 2 sin x plus c. Okay. Now divide by, because I need originally I, integration of this I. So divide by this 5, it is e2x by 5 minus cos x plus 2 sin x plus c dash. Now what is the c dash? C dash is your c divided by 5. So this is how we can integrate those problems in which you will get repeated terms, okay? Repeated, where you have to apply your integration by parts multiple times, right? And then again the original question appears, right? And which can be replaced as I to get the desired answer.